So yesterday, it's recording. Yeah. So yesterday, what we did is we introduced counting and we introduced counting and random variables, which we told that we'll do again today. So there were some solutions to the last two problems that we did. So there were some faults. I have added the solution to the end of that. So you can have a look at it. Which the solutions will become very clear once we discuss, go on discussing the rest of uh, the today's session. As we go ahead with today's session, you will understand why the solution holds true and so on. So as yesterday, someone, one of you were pointing, so I think he's not here today. Hussein was saying something. Oh, yeah, Hussein is here. So he was pointing to this Monty Hall problem. So we had planned that we'd start off with this famous problem. So what is this problem going to tell you? The problem is something like this. It says that you consider you have a game, right? So in that game, there are three doors marked as D1, D2, and D3. The objective is there is one player and one host. The host, so one of this door contains a car, right? One of this door contains a car. The other two are empty. So nothing is there. Or somebody in popular culture, they people say there are goat and inside the gate, for example. So now what is done is when the game starts, you are told to select a car, select one gate. Say, and please feel free to stop me and interact. Say participant chooses choose gate 1. So if it chooses door 1, what the host does, or it was a famous TV show known as by conductor Monty Hall. What did he do? He opened either of these two gates, either of these gates, right? And he only opened gate without a car. So you tell me, so if you had originally selected a door with a car, he would open either of these two with probability half. Do you agree?
Yes, Vata.
Yeah. So similarly, if you had selected this S2, then he would have only selected this with probability 1, right?
Yes.
Because when he is only going to open an empty gate or door here. So what happens is after opening the door, he gives you an option of to switch your choice. So what should be your strategy? Can you give me an intuitive solution and then we'll go to our conditional probability way of doing this thing. So you select. So if you are, so there are two strategies possible. You can either switch or you may not switch. Right? So if you switch, what is your probability of winning the car? And if you do not switch, what is the probability of winning the car? Can you tell me, like, without doing any math, can you tell me what should be your strategy?
So at first, if I choose gate one, then
Hmm.
if I switch, then probability will be zero.
Correct.
And if I not switch, then it will be one.
Then you are actually doing a so for your switching, if you choose gate one, you're having one probability. But I'm telling on, like, what is the probability of you winning, irrespective of your choice, if you switch. So that would depend. If you say, if you do not switch, what is your probability of winning? If you do not switch, you select one door and you don't switch. So what is the probability that you win?
One
Like
third.
without, huh?
One third.
One third.
One
Why?
third.
Why? Why not 1/2?
Because there is
Because
only one door
there's
with
no
the
floor.
car.
Very good. So you will have a probability of 1/3. So it may sound very, very non-obvious, because once you show another door, after you have been shown, there is equal probability of either of the two doors having a car. But that is not true, since because you started the experiment with all the three doors and only one of the three doors had the car. And the Monty Hall opening the other door is actually revealing to you that either of the other two doors have the car, and it's giving up and it's losing some chance of winning the game, because it's going to, I'll think of it this way, I'll come to the how to think about it, but let's do the math. So if you switch, you have a chance of 2/3 winning. Do you agree? Without doing any math, because you are likely to make a likely to make an incorrect choice in the beginning. That is 2/3 times. Out of 2 out of 3 times, you are likely to make an incorrect choice. Do you agree? So on average, you will make 66% of the times you will be choosing the wrong door. So if you're switching, all of those times you're going to win. So into 1 is the probability of winning. So if you are making an incorrect choice, so this is the idea. So incorrect choice plus switch has probability 1. So and incorrect has probability 2/3. So 2/3 into 1 is 2/3. Agreed? Any doubt? So yesterday we had a question saying that if you have n doors, so if it is not obvious, think of it this way. So you may have n doors, right? And in step 1, you're told to select one door. Say you select this door, and Monty Hall opens all the other doors. Then what would be the probability of you winning if you switch? It would be n-1 by n, right? If you are putting the this, what is the car equally in all the behind every door, if you are putting that. Do you agree?
Yes.
Yes, sir.
So because only 1 out of n times you will be selecting the correct door, and all the n-1 times you'll be selecting a wrong door, which you will be corrected. So rest all the doors are opened after step 1. So you'll be left with only two doors, say this door and this door which has the car. This you are selecting. So since you have opened all the other doors, so you're most likely that you have made a wrong choice. You have your choice of making your probability of making a wrong choice 1 by n. So was n-1 by n, that is the probability that you will be winning the car. So let's see how we'll formulate it using events and probabilities. So like intuitively we have answered. So can you tell me some events and like events by which we can do this? What is an event here? So let's give 3 events here. So win would be, let's write win as a event of winning the car, right? Let's write EI as the event of selecting, or let's say di, it will be easier to understand. Selecting door I, okay? And S, the event of switching. So can you tell me what should be the probability that you need to find in the question? So if you are trying to find a strategy on switching, so what should be the question? What should be the probability based on these events that you want to find?
Like probability of winning given that we switched at.
Oh, very good. That's it. So that is what you want to find, right? Now, can you directly find this, or should we condition more? So conditioning is always very important, since we have given only switching. So switching is not enough information for me now, right? Switching is not enough information. Do you agree? So if I can switch from door one to door two to door three, and so on. Do you agree?
Yes.
Correct. So
Yes.
let's say you do you agree that if you start with D1 or D2 or D3, all of them have the same probability of switching? So winning if you switch, because you have randomly put the car under behind any door, so you can relabel any door as you want. Do you agree? So they are symmetric. So if you find the probability of with respect to one door, that will be enough. Do you agree?
Yes.
Okay. Now let me see. So let us start. Let us say that door one has the car, for that without loss of generality. So I can say something like this. Let us from the it will be the sum of probability of winning. We are using law of total probability. Win and say door I, selecting door I given S for I equal to 1 to 3. This you can write by law of total probability we saw yesterday. So we are correct. So we are saying that we probability of winning, provided we had selected door I in the beginning and then we switched. So this can be written as I equal to 1 to 3, use Bayes rule, win di comma s into probability of your winning given that you selected door I and probability of door I that you select door I, right? This you can write it this way. Agreed? By Bayes rule, think that you're always switching. You don't consider this variable. Think that this is constant. Then you can write this way. This is the same. Just think that this is constant in some way. This is because you're always finding about switching. You're going to switch. That is fixed. So you can condition that you selected door I and into probability of di. So we had seen yesterday that probability of A can be written as probability of A given bi into bi if bi's are mutually exclusive and exhaustive events, right? Any doubt?
No.
Okay, so tell me what would be the probabilities. So which are the probabilities that we need to find? Probability of win given d1 comma s, probability of win given d2 comma s, and probability of win given d3 comma s. And what is the probability of d1 equal to d2 equal to d3? All these things you will tell me. So let me see if you understand.
1/3.
Yes. So what is di? Di is the event of selecting door I. So you will be selecting initially randomly. Of course, you're not. For this problem, there is no bias towards any door. If there is a bias, you can incorporate that. Agreed? So you can select equally from each door, can be each door selected randomly. Now tell me, what is the probability that you win?
1 by 2.
No, see, tell me, if you, what is the probability that you win given that you selected door 1 and you switched? Look at the picture. So what is the probability that you select, that you, given that you selected door 1 and you switched?
2
What
by
is the
1 by 3 into 0.
0? Not only 0. So you're given, right? You're given that you selected door 1. So you had initially you have selected door 1. So what will Monty Hall do? Let me write it down. Monty Hall will open either 1 or 2, right? Monty Hall opens 2 by 3. If you select door 1. So, and you switched. So if Monty Hall opens door 2, you will be selecting door 3, right?
Yes.
So what would be the probability that you win? 0? That you will not never, right? It will be 0. Now if you select door 2, right? If you select door 2, what is the probability? Correct. Because Monty Hall will be forced to open door 3. Then Monty Hall will forcefully open door 3 and you will be, if you switch, you'll be ending up with door 1. Understood? Similarly, this will also be 1.
Yes.
Do you agree? So whenever you're choosing incorrectly in the beginning, Monty Hall will open the door which was empty, which has no other option. So you will, if you switch, you will always be ending up with the door which was correct, right? Now put the values here. So you will get 1 by 3 into 1 plus 1 by 3 into 1 plus 0, which is 2 by 3. Understood? So why I did this? Because it's an exercise to understand how to write down events, how to write probabilities with respect to events and so on. Okay. Did you understand, or anyone has a doubt? I didn't, only few people responded. So others, if you have a doubt, you ask me, or we'll go to the, now we'll just go into probability and random variables into details now. The next.
Can I just explain like the win d1 comma s? What does this like denominator?
Okay. There's no denominator. It's a conditional probability. Yesterday we did that, right?
Yes, like I mean I'm just pointing.
Yes. So you're saying probability of winning given d1 comma s. What does it mean, right? It means
Yes.
that given you selected door 1 initially, right? And you switched. What is the probability you win? Agreed? So you're told that you have selected door 1, which has the car. Okay. You have selected door 1, which has the car. Now, after Monty Hall opens between door 2 and 3, you switch to door the another door. Understood?
Yes.
No. See, so you have selected door 1, right? Initially, that is given by D1. The event of D1, see, event of selecting door 1. Okay. So initially you selected door 1. So given that you have selected door 1 and you switch after Monty Hall opens 2 or 3, what would be the probability that you win?
0.
Yeah, so Aditya?
Yes, because like d1 was the correct answer, so I have switched.
Yeah.
So there is no chance of winning.
So the event is D1. Event, do you
Yes.
understand? The event is of choosing initially is D1, and another event is switching,
Yes.
and the other event is winning. So given that you have selected door 1 initially and you switched after Monty Hall opened the other remaining one of the 2 doors, then what is the probability that you win? So you will not be winning because you will be definitely choosing a wrong answer. Agreed?
Yes.
Okay. So let's now
I will switch
go
the
into,
door.
yeah, go ahead.
I will switch the door if problem like this comes, right?
Yeah, I
So
can't hear you. Can you?
So I will just shift the door if problem like this comes, right?
Yes, you will always
If I
shift
shift
because
the,
you, then you will have a probability of winning 2 by 3 times. You should. Philosophically speaking, you may not win because once the game is planned, you do not know which one you'll be winning. But on average, if you are not counting yourself as a participant and doing the experiment with hundreds of participants, if everybody follows this strategy, 2 by 3 of them will win.
Achha.
Okay,
You
so
may
like
not.
in number of doors increases, like me changing is getting better, right? So because it is
Exactly,
2 by
because
3.
as number of door increases, say you have 4 doors now, right? Or 5 doors, and you select door 1, door 2 here. So, and it does not have the car, say door 3 has the car. So Monty Hall will be forced to open this door, and this door. So if you switch, you will be winning 4 by 5 out number of times if the door increases. Okay.
Okay.
If you have infinite doors, if you switch, you will be having probability of 1 winning because you will be always wrong initially. And Monty Hall will open all the doors that does not have a car. So did you understand, Hussein, that how it is different from derangement? Yeah. So let's go into now the crux of the what you will be using throughout your career now, which is random variables. So yesterday I asked you to solve that question, but I saw that none of you were able to do it properly. So let's do it today. So before we go on to understand Bernoulli, I had defined the from the sample what was a random variable. Can you give me the definition? Then we'll go and start.
A random variable is a variable which maps an event to a number.
Is it a variable?
No, function.
It's a function.
Okay.
Variables, functions take variables. So it's a random variable is a misnomer, you can say. It's a wrong naming. But since we use terminologies like this, it is okay to use it as a variable. So in your mind also, you'll be thinking it's a variable. This variable is taking value 1 and so on. But it is a function. Always remember that. From your sample space, which is this, you're going to map to a real number line. So let's see. So I'll give you a very simple example of a coin toss as we did yesterday. So you have this sample space, you have head, and you have tail, right? Say head is being mapped to 1 and this is being mapped to 0. This is an example, okay? So if we say probability of head equal to P, that is effectively saying probability of X is equal to 1 equal to P. Do you agree? So if your probability of head, say if you have a biased coin and 60% of the times it lands head. So here probability of X equal to 1 means what is the probability that X takes value equal to 1. Understood? Do you agree or not?
Yes.
So But we have seen that we define probabilities on the event space, right? These probabilities are defined on the event space. So how does this uh, comparison operation come into play? How does this operation? What does this mean? So what is the probability that x is 0? First tell me, then I will tell you what does it mean. Naively, you tell me what will be the probability of x equal to 0? Someone said half, other?
For the unbiased coin, half.
No, I have written for a biased coin, right? Probability of head is p, I have written.
So 1 minus
1 minus p.
Because there is a theorem that we have seen before, that probability of x is equal to I from minus infinity to infinity is equal to 1. So sum of all probabilities has to be equal to 1. Do you agree? Sum of all probabilities? Yes. So why do you think that this is going to be 1? I'll show you that as well. So can you tell me why is it 1? Can you tell me this? Why is this sum equal to sample space? So we'll come to that. Let's not think about it for some time. So you tell me, so if your x is equal to 1, what does it mean? So we have defined probabilities on the events, right? Not on random variables. Do we define probabilities on random variables? No, we define it on events. Do you agree? Random variable gives you a random variable gives you a number, right? It will give given a realization of an event, you'll put that event into the random variable that will give you a number, so that you can do a comparison operation like this. But I want to ask you, how do you define random variables on events? So not random, probably we define probabilities on events. Do you agree or not? And not on the random variable itself. So how do you map this to an event? What is x is equal to 1 mean? Can you tell me?
that I have one head.
Getting hit.
With the one cross line resulted
Getting
in a head.
and head. Getting and head. Very good. Who told me? Can you tell me your name?
Monisha.
Yeah, Monisha will told me that getting a head. That is head, which is also equal to. Do you agree if this is a function? If it is a map between two random variables. So this is a valid function.
Yes.
Is this a valid function?
Yes,
No.
because
No.
No, one to many is cannot be called a function.
So this is not a, remember this. So you can't have functions like this. This is a relation. So if for one value of, so if you put function always for a particular value, it's going to give you one more value. A fixed value. It cannot give you multiple probabilistic values. Do you agree? Function will give you a fixed value. Okay, Monisha?
okay.
Yeah. So your x is equal to say 1. So in our case, what does it mean? It means that what is x inverse of 1? So what is your x inverse of 1? Yeah. Head. So x inverse of 1 will be head. That's the idea. So formally speaking, we have seen Bernoulli now. Bernoulli is a coin toss. So formally speaking, if you have a sample space like this, okay? Do you agree? And you have a subset of it that maps to C. Say for example, if you toss a dice, say all the even number, if you have even numbers, you have 1 probability. If you have odd number, you have probability 0, right? This example will give you a very good understanding. Let's understand this. So define a random variable x, which is equal to 1 if a dice lands on an even number, equal to 0 if it lands on an odd number. So you tell me what will be the map of the random variable?
X inverse 1 equals 2, 4, 6.
Very good. So I will know. I don't want so Brahmojit, right? So Brahmojit, don't tell me the answer directly. I want to show everyone that let's draw the mapping first, and then we will do the inverse. So your dice can land on not 0. Sorry, too much computer science. 1, 2, 3, 4, 5, and 6. Agreed? You can have all this as your outcome of a dice. I just want to show that a random variable can have multiple values giving you the same value realization. And so now tell me, what is the codomain set or the x of omega set or your range set? What is the range set? Someone other than Brahmujit, tell me.
1 and 0.
0 and 1. So your range set is 0 and 1. What is your domain set? 1 to 6. Dice roll. Outcomes of a dice roll. Now tell me, other someone else, what would be mapping to 0?
Odd numbers.
0 odd numbers means 1, 3, and 5. Agreed? This is your map X. Similarly, what would map to 1?
Even numbers.
Let me put the red one. 1, 2, 4, and 6. So what is the if you close your eyes and tell me, if I ask you what is the probability of x is equal to 1? Someone else other than Hussein, Brahmujit, and Aditya, tell me what is the event that probability of x is equal to 1?
Half.
No, it's what is the event? So I want the event probability that I'll divide on the event, right? Which is an element of the event space, which is a subset of the sample space. So what is the, I want you to tell me what is x is equal to 1. What does it mean? What is the set?
That is, we have got the even numbers 2, 4, and 6.
So it's first step you will write is x inverse 1. The x inverse 1 can be a set, right? It may not be a one-to-one function. So inverse functions, so it's not an inverse function. We remember we are going to use this as an inverse relation. So you may have studied that function inverses exist only for a one-to-one map. So but for this, we would list down all the numbers that map to 1, right? We'll do an inverse relation. So what would be x inverse 1?
Even numbers.
Now tell me the numbers.
1, 3, and 5.
1, 3, and 5.
Oh, sorry, 2, 4, and 6.
2, 4, and 6. So what is the probability of getting this set? 3 by 6 equal to half. Now do you understand what does this mean? So it means, so I've written it here for a random variable giving value c. It means x is equal to c means that x inverse of c, which also means for all the events in the sample space, which one does map to c? This picture is this same mathematical statement, or do you not understand this mathematical statement? Do you agree that X inverse C means all those events? So every element in the sample space, you will select all those elements that is mapped to C by X. Do you agree? I hope now the meaning of random variable is crystal clear. Now, if it is not, you tell me, because from now we will be using random variables and not coming back to events. So you will be having to understand the events in the back of your mind and have to do problems based on the values of the random variables. Do you understand what it means? If you have a doubt, tell me. I won't proceed up before that.
No, sir. Okay.
Okay, I hope it is very clear. So whatever mapping you are doing, you take an inverse map. Look at this picture for a particular value of C. You do an inverse map to this set. So if you have a small set, this, say this capital W, script W, which is the subset of omega. So your X inverse C will give you capital W. Okay. And then you can define, because do you agree this is a part of the event space? Element of the event space? We had seen yesterday, because it's a subset of the sample space. Any subset of the sample space will be a part of the event space for our definition. Yes or no?
Yes.
So for every element of the event space, there is an associated probability.
Yes.
So if you are able to take a pre-image of the random variable, you will get an event, and that has a probability with this probability definition. So that's why we are taking an X inverse, because it's defined on events and not on random variables. Remember that. Anyways, let's do binomial distributions now. So yesterday we said a binomial distribution or binomial NP means that for n experiments, what is the probability of n k successes where k is less than equal to? So you tell me. So you have this, right? So I, j would be the indicator telling me probability of success in the jth trial, right? So what is the probability of success in the jth trial? Can anyone tell me?
Yes. So like J minus 1 failures times success
No,
in J.
no. J means probability of success only in the jth trial. Rest you will not consider only. So your x ij is no. What is probability of
Sir, is it P?
Correct. Who said?
Sir, Monastrija.
Okay, Monastrija. And don't call me sir, anyone, please. You can call me Dada or you just call me Moinak. I don't have a problem. See, but it's one. It's because each of these are Bernoulli random variables, right? They can either be 0 or 1 based on success at the jth trial. So if you toss the coin 5 times, what would be the probability that the third toss would be head? It would be half if it is a unbiased coin, right? Similarly, half for the second coin as well, half for the first coin as well. We're only considering the event that the jth trial is a success, the way you define a success to be. Do you agree? Yes or no?
Yes.
Understood or no? Okay. So you tell me, yesterday we did this sum. So what would be the probability that x is equal to k? If k less than 0, what would be the probability? And if k greater than n? First you tell me this.
K less than 0 is 0, K greater than n is n. We cannot have like negative times it.
You cannot have more than n successes and you cannot have negative successes as well, right?
Yes.
So for all k belongs to, say, integers. So what is the probability that you have k successes? So do you agree that x is equal to k? Probability of x is equal to k means probability of k ones and n minus k zeros.
Yes, sir.
So out of this, you will select only k random variables, right? K random variables will have a success, and on the rest of the n minus k random variables, you will have a failure. So what will be that probability? So you select out of n k of them, and you have success on them. What is the probability of having success? P to the power k. These are also called IIDs. What does it mean? Identically and independently distributed. So we have seen probability of A comma B is equal to probability of A into B if they are independent. So every coin toss is independent. So you can, for k of them, you can have P into P into P into P into P k times. Do you agree? This is only independent. Because of independence, you can do this. If there was no independence, you cannot do. Similarly, 1 minus P will be n minus k times. Agreed? This is so you will have n choose k, P to the power k, n minus P, 1 minus P to the power n minus k. Yes or no? Or tell me if you do not understand. I will tell you why is it a binomial distribution.
No, understood.
Now you tell me why is it called a binomial distribution? Do you remember the binomial theorem that you used to have, right?
Yes.
So what would be the coefficient of x to the power k? Can you tell me from here?
NCK.
N choose k. Why is it n choose k? Because you will be selecting k of these, choose k from n. Which k of the cofactors you will be using to product k, x, right? Do you agree? You are going to choose which of the out of the n. So if you have 5, so out of the 5 1 plus x's, you can use any 3 of them to get x cube. So you can do that in how many ways? N choose 3 ways. For 5, choose 3 ways. Agreed?
Yes.
So this is the exact same reason this is called a binomial theorem, because each of the individual things use a Bernoulli, where you can either select that or not select that. But finally, you will get a coefficient of k. Do you agree? I think this is very clear. Others? If it is not clear, ask me, because the rest of it will be dependent only on this. Monoshrija and Monisha, and then what is, I don't see any other, Orpon, Shubhajit. It's clear, right?
Yes, sir. Yes,
Mondi.
sir.
Okay,
Yes, yes.
okay, good. Now, before going into more distributions, let's see how do we. So these are called distributions. This is an example of a distribution. This is an example of a distribution. So why is it called a distribution? It will become very clear. So because for every k, every realization of the random variable, there is a probability associated with it. So that's why it's called a distribution of the probabilities for the random variable. So anyways, so we'll be seeing more of these distributions today. But before that, we'll be taking some tools to know, since you have, so each of these values, say 1, so these are x values. x equal to p and n. So each of them have some probability. Do you agree? So p of x is equal to k. There's a distribution of probabilities for each of them. So if I want to summarize, what is the mean of this probability? Mean. Variance. We'll see what are these. What is the type of the distribution? What is, how is it uniformly increasing or decreasing? Does it have something like a uniform scale? Something like this. If we want to do some characterization, we would need to understand the overall characteristics of the random variable. And for that, we would need expectations, variances, and we'll be able to understand, categorize these and understand the behavior when you will be getting a realization of this random variable. What does a realization mean? So for example, if you do an experiment like a coin toss, you know that is a Bernoulli distribution. And if I tell you that this Bernoulli is a 60% Bernoulli 0.6 distribution, you know that immediately that if I do this experiment 100 times, around 60 times I'll get a head. We will see these in details as we go forward, but you will know this immediately, right? So what is the distribution that you have, and so on. What can you expect from a random variable? What numbers can you expect? If a random variable does not take a value at minus infinity, minus 100, so you will never be able to get minus 100. So probability will be 0, and so on. So we'll be trying to characterize each of these properties of the random variables. So in your school days, if you were told to find the mean of this, what you would do? You would do 1 plus 1 plus 3 plus 3 plus 3 plus 4 plus 4 plus 5 by. Do you agree? You would do this. What does it mean? What would this mean? You would multiply 2 times 1, 3 times 3, 2 times 4, and 1 times 5. And then divide by 2 plus 3 plus 2 plus 1. Agreed? So this is total number of n. So you would get on the numerator 2, 9, 8, 17, 19, 13, 22, 24. 24 by 8, which is 3. You'd get this. So you will tell the average value would be this. So average would be the number of times we used to do tally mark. So 1 appears 2 times, 3 appears 3 times, 4 appears 2 times, and I and ni, and 5 appears 1 time. So if you are told to, you would do 24 summation of ni, which number of times you do the experiment is 8, and then you used to divide to find the average value. Agreed? Yes or no?
Yes, sir.
Yes.
So can you tell me that this ni by summation of I, this can be explained as an empirical probability? So for example, if doing an experiment, 1 appears 2 times out of 8. So you can tell roughly, if you do 100 times and you appear 200 times, you can roughly say that 20% of the times this happens, right? Or if you do 800 times, 200 times this one happens. So you can say 200 by 800, around 1 by 4 times 1 happens. Yes or no? So probability of that happening can be written as number of time it happens by total number of times you did the experiment. So if I replace ni by summation of this by probability of pi, which is the empirical probability, so you get the empirical mean or mean from data, saying that the probability of the ith occurrence into the value of the ith occurrence will give you, if you sum over all the types of occurrences, you will get the empirical value. Do you agree? So that gives you the understanding of an expected value of a random variable, which is defined as the value that the random variable takes into the probability that the random variable So we'll explain this. So we have seen the empirical mean can be written as I into ni by summation of I ni. So you have k types of observations. So k type of observations. So for this, if it was a random variable in any sense, so you would say the random variable taking a value x. So your random variable from your omega is going to map to some values, right? Say was 0, 1, or say x1, x2, x3, and xn. Okay. They will map like this from the event space or from the sample space to your real number line. Agreed?
Yes.
So what are the type of values your random variable can take? X1, x2, x3, and so on. Yes or no?
Yes.
So you can say xi, and if you do an inverse of this into probability of x inverse xi, you will get this is exactly these two are same or not. So this this thing and writing this thing is same or not. So all the values that your random variable is taking, it's a weighted mean, right? So you'll say you take 25% of the times value 1. So and 25% value 2 and 50% of the times value 3. So you will get something like 1.5 plus 4.5 by 3. So something around 1.75 or 2 point something you'll get 1.75 something like that. So for these probability that what is the probability that you're getting a event xi or a random variable realizing to xi. So the inverse of that will give me the probability of some events here which maps to xi, right? And it has some probability. So if you write this as probability of E1, that is enough. Yes or no? Or this is also probability of EI can also be written as x is equal to I. So there is a bit of a overload of operators. Can you tell me what the different x here are? In the left hand side of the board. If you have understood, tell me.
Capital X is the like random variable here.
Random variable, very good.
X is our domain set, like these some
Which x? With script x, small x?
x sorry, the X belongs to capital.
This is script x.
Yes.
So this is the random variable, expected value of a random variable. So this one you are saying is this one is a element of the range.
Yes.
Element of the range set. This is the range set.
The range set.
And you have already used small x, element of the range set. And these are the random variables. P of x is written because probability is defined on the events of omega, f, and p. We will not go into change of that. So P of X would map you back to that event space. Agreed? So for every, we'll do some questions, it will be very clear. So it will not be a problem. What happened? There are not a lot of people. What happened? Some no. Okay. Next, what should we do? So I will ask one of you if you have understood what is the expected value of a Bernoulli random variable. Now recall everything and tell me what to do.
Like if success is P and failure is like
Success
1.
is equal to, so X is say distributed as Bernoulli P. So X is equal to 1 is P. Similarly, X is equal to 0 is
1 minus P.
okay. So what would be the
So
expected value?
expected value will be P only because like 1 minus P will multiply with 0 and it will become
Okay.
0.
So this is P X is equal to 1 into 1 plus 0 into probability of X is equal to 0. 1 into P plus 0 into 1 minus P is equal to P. Understood? Very good. Now we will see a property of this random variables and then we'll go to some, because this is very important to understand. This property is the most important property in all of statistics, which is probably the second most important, linearity of expectation. For any random variable, whether they are dependent, independent, any random variable, the expectation operation is linear. We will show you, if I show you this, if you can show that, then it's very easy to solve many questions and many problems in research. You can just do, we'll see one random variable and multiply by n sometimes. So we are see if this is a random variable. Do you agree? 1 to n, sum of 1 to n, sum of random variable will be a random variable. So we have seen in binomial, y is equal to xy, x plus, or z is equal to x plus y. This is a random variable. So for values like some for a particular event or an outcome, x will give 1, y will give 3, then z will give 4. Yes or no? For the same outcome, z of omega is equal to x of omega plus y of omega. Right? So for a particular outcome, say this is 1, this is 3. So this will be 4. This is also a random variable, yes or no? So for that outcome,
Yes.
it is going to yes, that is right. So you see a random variable inside can be written, this random variable is equivalent to saying that I can just take the sum of the expectation. Right? So yeah.
Sir.
Yeah.
Sir, could you repeat the last few seconds because I got disconnected, I think.
I see. So I said that this sum of 1 to n that you have, that is a random variable. And when I'm taking expectation of that, I'm getting, it is equivalent to saying this is equal to sum of all these random variables, expectation of all these random variables, which are numbers. These are, expectation is a number. Do you agree? Yes. It's a single number. It is fixed. There is no, because we have summed over all the probabilities and you have seen that it's a single number. Okay, now how can you prove that your random variable, sum of random variable is actually linear? That is, how can you show this? So, for example, you need to show something like this. So for two random variables, say if I can show x plus y is equal to expected value of x plus expected value of y, then I'm done. by induction. Then x plus y will be one more random variable. Then I can add another random variable and so on. And then I can get this. Yes or no?
Yes.
If I can prove, just this proving is enough. So two are linear means x plus y is also a random variable. So you can keep on adding something to this and you will be getting some addition. So can you tell me how to do this? So let us say that this random variable is z, right? Which is equal to x plus y, right? Yes, Vivek.
No, sorry, the mic went on by mistake.
Okay. So your say your x is equal to x plus y is equal to z. So what is the expected value of z? So expected value of z is equal to expected value of x plus y. What will it be? It will be z belonging to z. Z probability of z is equal to z. Okay. Yes or no? I hope this is clear. What values are z taking? Yeah, so you are not audible, so you can be a bit louder. Yes. Can you be a bit loud? I think there's. Can everyone hear you?
Can you hear me? Hello.
Yeah. Yeah. Hello. I can hear you now.
Yes, sir. I think there was a lot of network issues on my side. So can you repeat this last part of they need to P or they record them?
Yes. So if I have a random variable z, so this is you. Do you agree that this is the expectation of the random variable?
Yeah.
So that z is nothing but x plus y. That's what I'm saying. Okay. So how do I? Yes. So what do I do now? That I get. So I have small z. So how can I bring into x and y into picture? Can you tell me? I can't hear you. Be loud.
That small z equals x plus y. So
Small z is not equal to x plus y. That is the mistake. Small z is the, so see, you have x, like you have this sample space which maps to some values in x and some values in y. So for a particular element here, it will map here, it will map here. And then these two will be added to map to z. So this is the thing. So your capital X plus Y, that is the random variable sum, should be equal to z. Okay, this is the thing that you have to understand. So this should be your random variables. Huh?
I mean that random variable is equal to x plus y. So x
Yes.
plus y into P of z equal to z.
So can you tell me once again?
Z into capital Z equal to x plus y, which is equal to the random variable z, small z.
Correct. So capital Z is the random variable. Small z is the realization of the random. That's what you have this. Yes. So small z is the realization. What value is x plus y taking? For that is, and you have a probability for that. Can you tell me how do you get this? How do you do this? So for x comma, so still now we have only z. I need to convert this z into x and y. Then only I can do this problem. So if I condition, so conditioning is very important. I say capital X is equal to small x, right? Okay. Am I audible?
Yes, sir.
So if I tell capital X is equal to small x, then what will be y? Given that x is equal to small x, my sum has to be equal to z. What will it be y?
Z
I'm only
minus.
very good. Z minus x, right? Into probability of x is equal to x. Do you agree? This is law of total probability, right?
Yes.
Good. Or you can say, if you sum over, z can be written as x plus y, small y. So if I write this as small y, right? So x plus y, x comma y belongs to x cross y, which are the, you understand, you can understand from here, which is also equal to saying summation of x plus y, y is equal to z minus x, x is equal to small x. Right? Now you can separate this out. See, if I separate this, x, probability of y is equal to z minus x into x is equal to small x. This is over x plus sum of y. Also, you can write y into probability of y equal to z minus x, comma x. I'm keeping x and y both here for the time being. Why am I keeping? You'll understand. See now, if I write this as y, initially as I had written, because your this y can be written as x minus z. Do you agree? For all these values of x minus z, z minus x. So similarly, I can write this as small y. If I write this as small y, so do you agree that this sum would be independent of y? So I can sum over all y's possible and x will take its value accordingly. I can see this as this way also. If I sum over all y, probability of x comma y, if I sum over y, you get probability of x. This is called a marginal distribution. Because you are summing over everything, all y's. So that will become y's will be eliminated. Similarly, if you sum over all x here, similarly, you will get only probability of y. So this is you will get x belonging to x, x p of x is equal to x plus y belonging to y, y p of y is equal to y, which is expected value of x plus expected value of y. So this step is very simple. So only catch here is from here. So what did I do? For every z, there can be, since we are taking two random variables, so there will be a omega for which x plus y will be equal to particular z. So I will be using that conditioning, that x is equal to small x and y is equal to, you can just put y here as well. There's no problem. Z minus x, you can just put equal to y and you can just say small z is equal to x plus y. Understood? Right. If I put small z equal to x plus y, I can just write z equal to x plus y and I'll just put y over here. Yes or no? Let's not write z minus x over here. Let's write y. Similarly, let's write y over here and x over here. So now there is no doubt, right? So if I sum over all, see here x is a constant. Here it does not, outside the sum does not depend on x. Do you agree or not? And here the outside sum does not depend on y. Yes or no? So you can add off all the y's, and will be only left with x distribution. So I'll give you an example. What is this? A intersection bi summation over all I. This is probability of A, right? If it is mutually inclusive and exclusive set. Yes or no? Yesterday we saw this, right?
Yes.
Yes.
So this is exactly the same. What does this mean? That y inverse, tell me what does it mean? Y inverse small y intersection x inverse small x. This is the notation. Now does anyone have the oh yes, I understand factor? Or it's still not clear?
It's like we are doing this because x and y are independent, right?
No, x, y, and y are not independent. They need not. Where do I assume x and y independent? I'm just using joint distribution. I am saying y inverse y intersection x inverse x. Where am I using probability of this into to multiply? Are these independent? Aito?
Like, can you just explain why, like, the distribution you have done in the right hand side, like where you're separating these things?
Okay. So I am saying that the z is equal to some small z. Do you agree?
Yes.
So z is equal to small z. I am going to convert this to saying that x plus y is equal to z, right?
Yes, because z is equals to x plus y. Yes.
Correct. So now I am going to replace small z, I am saying is equal to small x plus y. I'm just considering this. So I'm writing y as y minus x. Agreed? Z minus x. Conditioned on if x is equal to x. Yes or no? Into probability of
Yes.
x equal to x. This is just conditional probability Bayes rule,
Okay.
isn't it? So probability of A is nothing but probability of A given bi into probability of bi. Yes or no? Yesterday we did this.
Yes.
From here, you only told me the solution to how to prove this. So once you do this, you can also write it as joint probabilities. What does it mean? You mean that y takes the value of y, the random variable y takes the value of y, which is given by this, and the random variable x takes the value of x. So what does it mean? So for this x, right? So if these take a value of small x and this take a value of small y, only in this place will this be taking a smaller value of z? Right? Yes or no?
Yes.
So that's what I'm saying. So now when I am writing this like this, so the sum is there. This can be broken up as x into just by distributive property of a algebraic expression. I can break or not? X plus y into this one.
Yes.
Can
But
I?
yes,
Yes.
distribution.
Normal algebra, writing that's distribution of two things. Now, in this case, is there a y outside?
No.
So I can just first sum all the y's like this, yes or no? And then sum x,
Yes.
because there is no x, since there is no y outside. So if I sum all the y, this is effectively saying that I am going to sum over all disjoint sets such that y inverse of y is equal to that. So these are all disjoint sets, yes or no? Y inverse of y is disjoint or not? Because it's a function. So a particular value, two values cannot have the same pre-image. Yes or no?
Hmm.
So these are all disjoint. Yes or no? So for a random variable, y inverse of y for all y, does this form a mutually exclusive set? Because this is your omega and this is your, say, y. So you have some random variable y mapping here. Yes or no? This map is there.
Yes.
Can you have a map like this? This you can have, right?
Yes. Many to one.
Yes. But can you have this?
No.
So I cancel this for a particular value of y. So for this, you will have another value. Yes or no?
Hmm.
So y inverse y1, say, will be this set. Similarly, y inverse y2 will be this set. Yes or no?
Yes.
And if I sum over all of this or take the union of this is equal to, you only told me, sample space. Yes or no?
Yes.
That's what I've done. I've taken the intersection of mutually exclusive sets, right? Here. Now is it clear?
Yes. Yes. Understood.
Now these are all mutually exclusive sets, this intersection. So I can use this law of total probability to just remove y altogether and keep only x. So this is very, 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 very important, as no independence assumption is used. Only you use law of total probability. Okay?
Yes.
Happy? So
Yes.
you can use it for continuous random variables as well by just converting these to real rational numbers. And then you can put integral, those we will not do. So this is true for a discrete random variable. You can also do it for a continuous variable. That's what I told you today. So can you tell me what will be the naive approach is your homework. So tell me what is the expected value of a binomial distribution. So x is distributed as binomial NP. What will be the expected value of x?
NP.
Tell me what is the definition of our expected value?
Oh, so summation of x, yes, k times p x is equals to.
K equal to 0 to n. Agreed? So this is equal to k, n choose k, p to the power k, 1 minus p to the power n minus k. Right? So you can solve this algebraically to show it is equal to NP. Please do it using the naive approach at home. We'll do it, okay? Naive approach, you can post it how do you did it, okay? And please post it on the channel. Okay.
Sir, I have a question.
Go ahead.
In the previous section, when we were calculating the sum of expectations of two random variables,
Okay.
when we are writing x plus y, do we assume that x and y are from the same distribution?
Distribution. Now this is a very, very good question. So distribution, of course, distribution would be x and y can have different distribution, but your event space must be the same because you have to define that event space. You need not have the same distribution. They can have joint distribution, which is different altogether. But you can, but your event space, your pre-image that you're mapping, that has to map to the same event space. I think Monoshrija, you were there yesterday, right? I saw you yesterday.
No, sir, I missed the class yesterday.
Okay, you do something, go and see that we discussed about event spaces. So what happens is,
Yeah, I have seen the video, so.
Oh, then now you have seen that, then it's not a problem. So event space you have understood, right?
Yes. Yes.
So any subset of it's a collection of all subsets of the sample space.
Sample space,
So
yes.
yes, so if you take a pre-image, you will get a subset of the sample space. That will be an element of the event space, and every element of the event space has to have a probability measure associated with it, and that probability measure need not be same for both x and y, but those sets must be the same, x comma y. So you have your joint distribution will be maybe different. So p of x comma y may be different from p of x and p of y. We will see examples like this when you will do transformations and so on. So for example, x from this one can be sum of two coin tosses. One coin toss has a probability of 0.6, another has 0.8 probability. So your expected value there would be 0.1, 1.4, right? Number of heads.
Yes.
So it may not be the exact same distribution, but the events of those distribution must be same. But we will take them as same to have for similar. Otherwise, you have to make some assumptions and you have to make a higher subset using sigma algebra, which you're not going into. If you have time or you're interested, you can ask me late offline. We can discuss.
Sir, so for example, say if we toss 5 coins and we map that to a random variable, say the number of times I receive head, I can map that to a random variable, and I consider another experiment which follows the binomial distribution, and it has the same probability of success and failure. Like
yes, understood.
So can I add those two random variables?
You can, of course, but because your events are the same, you can always do that. So if say I'll give you, don't take a very difficult example, take a very simple example. Take two random variables x and y. Okay.
Yes.
Say one is a Bernoulli random variable, Bernoulli p random variable. Okay.
Okay.
Another is a Bernoulli q random variable. You can add them, right? But they're defined on the same head and tail space. That is very important. So the sample space, event space must be the same. Your probability measure may be changing, but the probability measure would be different for the x, the y, and x plus y. X plus y will have a single probability measure.
Okay, so I cannot add a random variable x that follows a binomial distribution and another random variable that follows the Poisson distribution, for example.
You can add, no problem. You can add, you can have joint distributions like that. You can have independent joint distributions, condition them. You can do that. But binomial and Poisson you cannot generally add because n would be very limited. So there you do not have an equal setting. So your event space may not be the same. You have to be a bit careful there.
But isn't there a limitation, like binomial distribution is for discrete variables, right? And Poisson is for
Poisson is also
right.
So you generally cannot add discrete and continuous variables like that.
Right,
you may,
for example, if it was exponential distribution and binomial, I could add it.
You could, I think you can. We will be able to see. We'll see, but you can still add two variables like that, provided that you can define that probability, joint probability. So whenever you are, so all you need to do is you have to define this joint probability. Yesterday we said na. So if you have multiple random variables, okay, you can add any type of random variable, but you have to define this probability. Okay.
Okay.
So your question is, say your x comma y you have, right?
Yes.
So can you add probability of x plus y is equal to some z? Yes, you can do it, definitely. But for that you will have to do p of z into p of x comma y and then do the summation over all z. And this must be defined, So if you see random vectors, you will be, we'll do that, you will be understanding more in details.
Okay, sir.
So your joint distribution must be defined. Then you can define anything. If your joint distribution is not you cannot define it, then you cannot.
Okay.
Yeah. So and joint distribution to do the since I am trying to introduce these things to you, the only reason I cannot talk to you about this measure theory approach because there is a bit of a gap. I'm trying to give you the exact abstract understanding, but there's a bit of a gap. Then you need to understand measure theory to understand appreciate it. How do you map the events? But then if we have time and people are interested in having higher level courses, we can do that as well. So you need to have that amount of understanding. Other than that, just keep in mind, if you can define a joint distribution, you can do that. Okay.
Okay, sir. Thank you.
And if you have a doubt, you can keep on asking any one of you in the group Teams group. That's why it's good to have student discussion in that. Okay. So now can you tell me, so you asked this question. So can you tell me how to solve this question? I think you can do it easily, right? So tell me how to do this expected value of X without solving this cumbersome binomials and taking differentiation and so on. What should I do without thinking of it? Without thinking of anything. So these are so can you go back to the definition and tell me? Okay, if you cannot tell me, I will not do it now. So let's do something which is known as the fundamental bridge in probability. What is a fundamental bridge? It says that defined on an indicator random variable. So what is an indicator random variable? Say you have an event A, which is a subset of the sample space. So this is your sample space. This is your event A, right? So IA of omega equal to 1, right? So what would be the PMF of this, or the probability mass function of this? Now you have to answer. This is very simple. Any one of you? What is the probability? So if omega belongs to A, do you understand how do I define an indicator? You map it to 1. You map it to 0. Yes or no?
Yes.
Okay.
Sir, can you please give an example of this so I can understand?
We will do example. So okay, can you? We'll do example, but I want to you to understand in this abstract space. Can you see this diagram?
Yes, yes.
So if you have
expected.
Okay, just a minute. So if A is a subset of omega, right?
Yes.
A is a subset, so it can have multiple outcomes from the sample space.
Yes.
Yes.
So if you have an outcome from the A set, then your indicator will say it is coming from A. If it is outside A, your indicator will say it's not coming from A. Then it will say 0, binary variable. Okay.
Okay.
For example, indicator, say you are saying very simple example, a dice roll. If you have an indicator which is saying from an event where it is less than 2. So your 1 and 2 will be in A. So in those cases, you will have a 1. Your event. So we'll do the example, will be very clear then. So what is the probability mass function of indicator of A? Then how do you define the PMF?
P. Suppose that P of E is equals to like 1.
Okay, good. Then what is that probability?
That is 1 when like something belongs to A and otherwise 0.
So it's A indicator inverse 1. Always remember this definition, right? Right.
Yes.
When is it 1? So this set, yes or no? Which is nothing but probability of A. Yes or no?
Yes.
Understood? Others, did you understand? So probability of P equal to 1 and similarly A equal to 0 would be 1 minus probability of A, right? Understood? Before I give an example, do you understand this abstract thing? So I have got the PMF. So if you have understood, tell me what is the expected value of indicator of A?
That is what I was asking. Like for expected value, don't we like need the like number of elements or like something like we are going to sum it up?
No.
So
Yes. So what is it summed on? The outcomes, right?
yes.
The outcomes of the random variables, that is 0 and 1. What does it sum on the range set, right?
Yes, with multiplicate, like it is the product with the like.
Yes. So it's 1 into probability of indicator of A equal to 1 plus 0
Yes.
into probability of indicator of A is equal to 0, which is probability of, what is it? A plus 0 into probability of A complement, which is 0 plus probability of A. So you see the expected value of the indicator is nothing but the probability of the set that you're using, right? Do you understand? So if I able to define indicators, so the probability of those indicators would nothing be, expected value of those indicators will nothing but be the probability of that event happening, such that there is a success for the indicator. Okay, understood?
Yes.
Now you tell me, so now someone of you, how will I solve the, let's do it at the end. Not enough space there. Okay. Expected value of binomial NP. What will it be? The hint is this that I gave you. Can you tell me the hint? What should I do? So what can X be written as? So what is binomial NP? N coin tosses, right? You are all saying binomial NP examples. Do you agree? Binomial NP can be written as this way. Binomial NP means any number of success given that you have n tosses. Okay, or n experiments with each having a success with probability p. So what would be your X? Expected value of X would be by linearity of expectation. What will it be?
E will be inside, like summation. Yes.
Summation of
Sigma of E into I of I.
So what is, let's write J. What is expected value of J? People, someone else?
P.
Why is it P?
As the probability is like P, so if we like toss it many times, we will get around P number of times
Number, no, P is a number of, it's just the probability. E of ij is P into 1 plus 0 into 1 minus P. This is just a the Bernoulli distribution. Right, so this is P. So this is P summation of I equal to 1 to n. So you can just write NP, right?
So can we say that these ij's these are behaving as indicator variables?
Yes. This indicator that the jth toss is indicator.
Jth toss has a probability of P.
Indicator jth toss is success.
Oh.
Or head, whatever you want to define this as. Right? So the probability of a success in the jth toss is P. So by fundamental bridge, the expected value is also P, right? So the expected value, you just put P. All of them are same. They are IID. Independent and independent. They're independent also. They're also identically distributed. So all have probability P. So you can just write NP. Yes or no?
So Nana, can I ask something?
Yeah.
What is the physical significance of this expected value?
Okay.
What does it signify?
Okay. So expected value means if you do an experiment many times, right? You do an experiment many times. That is called the law of large numbers. So what the value that you are likely to get is the expected value or the mean, right? You do, what do you do what did you do in class 11, 12 physics? For doing finding the focal length of a lens. You did it for 5, 6, 7, 8 times, used to do the same things and take the average value. Do you remember?
No, I mean, yes.
So if you do an experiment multiple times, so n number of times, the value that you are going to get on average empirically would be the expected value of the random variable. So on average, you would get the expected value. Is this intuition clear? So if you do an experiment very many times, so if you do sum this, so if you do x by n, you will get p. What does it mean? Means if you toss a coin n times, limit n tends to infinity, so you'll get p, because if you keep on tossing the coin, it will give you, by law of, we'll do that later, that the probability of getting a head would come up to be p. So here everything will be IID. So this is the physical significance. Expected value is the most likely value a random variable takes in the first order. For we'll see higher movements also. So for example, here this is the expected value in the center or the average. So if a player plays 100 test matches and has an average of 50, that means that he will keep on playing, the random variable being each innings, and you will be getting 50 runs per innings on the long run. That's the expected value. Understood? Okay. Let us do this question. So it says that let there be n cards numbered from 1 to n, and they're shuffled and laid with label L1 to Ln. So let us name them L1, L2, L3 ... Ln. And you are shuffling the cards and putting, say you have C1 here, CK here, and C2 here, so on. So what is the expected value that Li has the ith card? So what is the expected value of the number of matches? That is by that I mean how many cards will have the same label as the initial card. It's like that derangement problem, like, right?
Is it derangement itself?
It is.
It is something different.
It is, but you're trying to find the expected value of how many has one
Same
card. One card, yes. How many has it? Same card, exactly. But you cannot do directly by derangement. You will be like doing hundreds of pages of calculation. Can you tell me how to do it by hint is? Use fundamental bridge. This is a very, very popular question. You may be asked this in an interview if you are thinking of going to higher studies, wherever you want to. Like, you'll be this type of question will be definitely be asked. So you will have to do two things: define an indicator and then define the probability of the indicator, and then try to do a sum of those indicators. Anyone else other than the 3-4 people? So I want to say that the expected value that Li has the ith card. What is the number of such occurrences? Give me an indicator, right? So that Li has the ith card. How do I define the indicator?
We can
What?
define an ij that will take the value of 1 if Li is in the ith.
Very good. Bas, you're done. This is all you need to do. Li has the ith card. Once you have done this, this question is a cakewalk. Zero otherwise. So what is the expected value of ij, which is also equal to probability of ij? Do you agree? We have seen this. Since it's the indicator random variable, indicators have expectation equal to the probability of that event. We have already seen this here. Just now we have proved. So Monoshrija asked example. I am doing this example. So what will we do? Now, what is the probability of ij? Very simple, right? So ith card is in the ith place.
1 by n.
Correct. So the card can be in any of the other. So say card 1. You put card 1 in L1. And rest n-1, you will do any permutation. This is 1 by n. Or you can just think about it. 1 can be in any of the LIs. There is only one out of n possibilities that it is in own position. Both of them will give you the same answer. Right? Understood? So what would be the expected value of? You need number of matches. Expected number of matches. So what would be the expected number of matches? Tell me. Romojit, you only told me the ij. So what will it be?
NP. So it should be n into 1 by.
So let n be the number of matches. So n can be written as sum of ij's, right? You define this.
Sum of.
The number of matches is nothing but the sum of ij's. So number of times indicator becomes 1. That many times there is a match. Yes or no?
Yes.
So what is the expected value of n? You are told to find expected value of n. What will it be?
It's again like that problem only, right? Arranging.
Yes.
So it should be we are getting total n.
No, but you have already done this. You have found the ij. So you can use linearity of expectation.
Into 1 by n.
N into n by n. N into 1 by n. But so this is, you are trying to find expected value of n.
No,
Correct.
into 1 by n.
Calculate into 1 by n. So this will be second one has an answer of n-1. This you will do as your homework. Same process. So tell me, you have a doubt?
Yes, I
What?
have.
Value is 1.
So there on expected value is 1 means there will be on average one number of matches you will find is 1 match.
So
On
this means that if I'm doing this n cards, so
if
out
you
of if I'm doing this with n cards,
N card,
one will be in the
card
right slot.
match.
yes, on average.
And the remaining will not.
Remaining will not be. You can find out. The answer will be n-1 for no matches. You can check for with rest. This is
Will
so
be, I mean, in the same way it will be done, right?
It will be
in the same process, right? In which we have
exactly
done with
same process. Same process. You will be using that the ith card does not match the ith. So you will do again n times that, right? Since whenever you have an expected value, you will be like very happy because you can do this. So did you understand how did I do this sum of? So always try to use linearity of expectation. So each of the ij you will have a, since you can find this probability. So what are the steps? You need to find the step 1 is define an indicator. Find the probability of one of them. Finally, find total. Okay.
Dada,
Yeah.
this problem is linked to derangement 1. So in derangement, the statement was that a particular card will not be in its place is 1 by e.
Yes.
So the particular card will be in its place is 1 minus 1 by e.
No, that doesn't mean like that. So there can be in 1 minus 1 by e will have all those possibilities, which are saying 1 is in its place, 2 is in its place, 3 is in its place, and so on.
And one of them, by this bridge problem, we can find out one of them is actually in its place.
By this problem, you can say on expectation, one problem will be one. Every time you do the experiment, you will have one card in its place. If you do it 100 times, yes. So expectation and the probability are exactly not linked. Exact expectation is the average value a random variable takes, and probability is the probability of an event that is occurring. The random variable taking a value. That is the thing. That is the difference. So did you understand how did I do this? This is very essential. Did you understand? Others?
Yes, sir.
Yeah, you understood. Others? I'm happy to explain because this is the most important question of today.
You understood.
Sir, can you please explain once again? Like an indicator variable is 1 if the omega belongs to A and 0
Okay.
otherwise, right? So what is A and what is omega in this case?
So
I understand
omega.
one of the
Okay, tell me.
events is
A would be an event here. So just when you're thinking of this, think of this way. A will be an event where you are having the ith or the jth card in its jth place, right? Okay. You can.
yes. Okay.
That is the event A. Agreed?
Yes. Okay.
So for example, if you have 4 places, you can have 1, 3, 4, 2. 1, 2, 3, 4. These all belongs to the A set, right?
Yeah. Okay. Okay.
And any permutation will belong to the omega set.
Yeah.
So, tell me once, what are the steps that you will be doing while you are doing this question? So this time, let us do this second question and you help me out. Since you asked, let us do this second part. So ith card is not in its no match. So what is the probability that you have no match? That is, ith card is not in its ith place. So how many times will you see that this happening? So how will you define an indicator there?
Following the previous example, I can define the indicator variable as indicator variable takes the value 1 if the Lj is not in the j place.
Does not have
the
the
j
j card and 0 otherwise.
0.
So what will be the probability of ij, which is also equal to expected value of ij? This thing you have understood, right?
Yes,
Probability
yes.
of, yes, fundamental bridge you have understood. So what is the probability of ij?
Probability of ij. So I can choose any of the the other spaces. Like for example, j cannot be in the jth place, so I can choose any of the n-1 other spaces.
Okay, n-1. You choose one
By
of them.
Yeah.
So
And
okay, you are saying n-1 by n, right? Correct.
Yes.
Directly, yes, very good. So what will be the number of expected value of the number of times number?
Summation of I.
This will be
Summation of expectation of I.
so linearity.
Yes.
So each of them will have
the n-1 by n value.
Yes, so n into n-1 by n.
Yeah, so that is
good. So n-1 of them will not have their own cards.
Okay.
Understood? Now the fundamental bridge is clear, right?
Yes, yes.
That's good. So let's see another very important thing in probability, that is known as LOTUS, or the law of unconscious statistician. It says that if you have a function that is mapping from a real number to a real number, so a function of a random variable will give me this. So we had, remember, E of x is equal to, what did you have? What was the summation? X into probability of x is equal to x. So if a statistician was sleeping, what would you have done? He would have put f here and he would have put f here. So that's why it's by in popular science, it's called law of unconscious statistician. The statistician was sleeping, so he put this f anywhere and it worked. So we'll see that it is working. Why does it work? Can you tell me? By now you should be able to tell me. So I'll give you a hint. This is your omega. This is your x of omega. And this will give me f of x of omega. So let's do it. If you do not understand at every step, you just stop me. It's very simple proof. Let's do it. So let us write y as a random variable, which is equal to f of x. Okay. So a function of a random variable will also be a random variable because your x will map to some value in your range set. Do you agree? And your function will map deterministically to another value in the f of x set or the range of x set. Yes or no? Once you have realized the event, this is fixed. Do you agree? Okay, someone of you, if I ask you, say head. So let us take this example. Head comma tail is being mapped to -1, 1, or say 0, 1. This is your x. And then I am doing x plus 1. What will it be mapped to?
1, 2.
1, 2. So if I get a head, so what is y? Y of head?
1.
1. Similarly, y of tail will be 2, because this is f of x of head. Simple composite functions. So x of head is 1, which is also equal to 1 plus 1 equal to 2. Simple class 10, 11, class 11 level sum. So now tell me, how do I write expected value of y? So if I am able to write the expected value of y, I'll get this easily. So expected value of y is nothing but expected value of f of x. So what is expected value of y according to definition? yi into probability of y equal to yi. Yes or no?
Yes.
If this set is y, script y, this set is script x. Okay. Now what is yi? This is nothing but f of some x. So your every yi can be written as some f of x. Right? For every y, there is a pre-image, right? There can be multiple pre-images. Like for this, there can be only one what am I saying? F is a function, so there can be only one pre-image. Do you agree? Oh no, there can be multiple. If many to one function, there can be multiple pre-images. Right? Right? There can be multiple pre-images. You can stop me if you want. Tell me, ask me. So
E of y can be written as iy into p of iy. That is from the definition.
correct. This is what I've written. Now what will I do? So I will write y as f of x. That's what I will do.
And the same way I'm writing that head tail example.
Same thing, same way we did the sum of two random variable examples. So your y is nothing but this, f of x, right? Y is nothing but f of x. I have defined y as f of x. Yes or no? This is the random variable. The random variable takes the value of f of x. So your x must contain f inverse of y. Do you agree? Y is nothing but f of x. Yes or no? Why I'm writing not equal to, because you can have multiple values in the pre-image. Yes or no? I'm taking just inverse. So for example, if this was x equal to 0, so then what would be the inverse? So if I was mapping this to a constant function 0, so what would be the inverse of 0?
Head.
0 would be both head and tail, right? So your 0, 1, I have a function that maps it to 0. So the inverse of 0, f inverse 0 would be 0, 1.
0, 1.
Yes, and then the inverse of that will be head, tail. Right? So you can have your functions can be many to one. Do you know that? You know that, right? This is a valid function, yes or no?
Yes.
Yes.
So if I take an inverse of this element, so I should get both these two elements.
Yes.
So that's what I've written. So all the x's that are belonging to the inverse, so the inverse will be a relation. That's what I've written. So x1, x2 will belong to f inverse y. Now it is clear. So nothing but f of x, probability of x is equal to f inverse y. So this is nothing but x belong to script x, f of x, probability of x is equal to x. So for any function, you can directly use the function directly. So what does it actually mean? It's relabeling. It means this. So you'll be doing a few examples at home, you'll be understanding. See, what does it mean? If you have a pebble world, right? So each pebble, here there's one pebble with probability half. So you have probability half here. For a random variable while taking value 2, you have probability 1/4. 3, you have a value of 1/4. So if I map a function from here to this, x square, so 1 will become 1, 2 will become 4, 3 will become 9. Do you agree? Yes or no?
Yes.
The probabilities will not change. Will they change? Because this mapping is from the event space, this is being mapped by x. Are the probabilities changing? This is the intuition. Only the labels are changing. You're changing the label of the random variable, not the probability of it becoming 9 or something like that. Yes or no?
Yes, the probability hasn't changed. So,
Because, say, I'll give you an example. Say you have event 1, event 2, and or not right event. Outcome 1, outcome 2, and outcome 3. 3 outcomes. Take this simple example. O0 maps to 1, O2 maps to 2, and O3 maps to 3. Okay? By x. Happy? Now if I map x square, y is equal to x square. What will 1 map to? What will 2 map to? And what will 3 map to? Tell me.
1, 4, and 9.
1, 4, and 9. Now if I say y inverse of 1, which is nothing but saying, what does it mean? So if I say y inverse of 1,
It means 1.
y inverse of 1 is x inverse of 1. This 1, right? So let us not do 1. Let us do 4. So what is y inverse of 4? So y is nothing but f of x. Do you agree? Or f of x of omega. Agreed?
Yes.
So what is y inverse? X inverse of f inverse of something. Right? You remember that inverse functions will be reversed in order.
Yes.
So your first f, you will take an inverse of the first step. So it will be 2, right? From 4 you will get. So you will get f inverse of 4, and then you have x inverse, right? So f inverse of 4 is square root of 4, which is 2, which is nothing but O2. Do you understand now that the probabilities are not changing anywhere? It's just the relabeling that is changing. Okay.
It's clear.
Yeah. Think about it more today, so you'll be very clear then. Okay. So here I have written some another property of a random variable, which is also called a variance of a random variable. What does a variance of a random variable mean? So for now, we have seen, what did we see? What was the most likely value? Yes or no? Right? Which was the most likely value, correct? Am I audible? Okay, and now, how much does a random variable deviate from the likely value? How much deviation on average? If I ask this question, so what will you do? How will you try to find it? There is an option of doing expected value minus this you can do. right? But can you do this? What is this? By linearity, expected value of x minus expected value of mu. What is expected value of x?
Most likely.
Mu. Mu is the expected value. I'm saying expected value of x, I'm writing it as mu, okay, for the time being. So what is the expected value of a constant?
The constant itself, so mu.
This is 0. Why is it constant itself? Because you see, so mu by law of unconscious statistician, what you can write? Probability of mu into probability of x is equal to x. X belongs to x. So mu is constant, you can take it out. What is the sum of x is equal to x? 1. So for any constant, the expected value is just a constant. So we can't do this. So an option would be on magnitude. What is the difference? So we are seeing here it is not magnitude, it's on sign is also being taken. So if you are taking magnitude, since the square function is a simpler function to deal with, we squared this up and then take the square root as a standard deviation, also known as a standard deviation. Okay. Similarly, for multiple random variables, we'll see how to do this. Now, we can define this as the product of x minus expected value of x into expected value of y minus expected value of x. And this is also known as the correlation constant. We'll do the questions, will be clearly clear. So did you understand the intuition between the between variance behind the variance operation?
Yes, sir.
Yes, sir.
Okay. So now you will tell me what is the variance of a Bernoulli random variable. We'll do this question in 5 to 10 minutes. We'll complete most of it. And then we can go to the last part. You have all the tools now to solve these questions. What is the variance of a Bernoulli random variable? What is the mean? So let us see how to do it. Let's do for one and then you will be understanding. This is one option how to solve this question, but sometimes it may be easier to do this because you will always know the mean beforehand, right? It may not be easy to do this summation. X minus mu may be very tiresome because it's recentering and all, right? It may be very difficult. It may this you have to open this square up and so many things you have to do. So let us see if we can find another very simpler solution. So what is this square? X squared minus 2 x expected value of x plus expected value of x whole square. Correct? Yes or no? So by linearity of expectation, what will it be? I'm just writing square of this.
Minus 2 expectation of x square minus 2 expectation of x is square of this and plus expectation of x square. Sir, expectation of x a square, not x square.
Ah, that is true. I just wanted to just right. So this can also be written as expected value of x square minus mu square. If you find the mean, you can just subtract the mean from the. This is also known as the second moment. We'll see later. Why is it called the second moment? Mu is called the first moment. Anyways, so that is not very important thing to understand to note now. So, did you understand? What did I do? Did you understand why this became product of these two? Someone else?
because the expectation of x is a constant, so constant will come out, and 2 is another constant will come out.
This is constant, and you are taking expectation of this variable. Very good. Now tell me how to solve the variance of Bernoulli. Variance of x is distributed as Bernoulli P. How do I solve?
Sir, mean is P, and
okay.
If we take the expectation of x squared, so
okay, what is expectation of x squared?
The range of the random variable is 0 and 1 for success and failure.
Correct.
And so if we multiply that by the corresponding probabilities,
so 0 into 1 minus p plus 1 into 0 square, right? 0
square plus right. 1 square.
P minus p square, right?
Yes.
So you have p into 1 minus p. So if you let us write this as q, so it will be p in q. Okay. This is your variance. So standard deviation of x will be root over of pq. Okay. Square root of variance is the standard deviation. Why do you do it? Can you tell me the intuition? Why am I doing a standard deviation by taking a square root? Why am I taking a square root at the end to get? Because standard deviation is a widely accepted number everywhere in the world, not variance. Why is it that standard deviation is accepted? I hope it's very simple. Just think of your class 11, 12 physics. You used to do root mean square error, remember? Because your mean square error is mean of the square of the differences, right? So the magnitude is squared. So if you are doing centimeter, your variance will be centimeter square unit. The standard deviation will be
linear form. That is why
exactly. So if, for example, if you are doing height, your variance will be in the unit of centimeter square, right? Or feet inches square. Do you agree? And then standard deviation will again give you in the feet and inches instead of having this. Now let us do for variance of binomial of NP. Why I wrote this covariance, we'll see now. The binomial of NP, before we do, let us do for two random variables. So variance of x plus y. Can you tell me what to do with this? What is variance of x plus y? So let us do number 2 first. So binomial we'll do later. So we'll first do variance of x plus y. What is the thing? Go ahead.
Variance of x plus variance of y.
No, it's not linear.
Sir, it will depend on if x and y are independent random variables.
It will, yes. So can we start from the basic theorem? So what is a variance definition?
Expectation x plus y whole square minus.
No. You tell me the basic first definition. Go ahead. Minus expected value
of x plus y. Yes.
Correct?
Yes.
So this is nothing but x plus y minus, let's write mu x minus mu y. Expected value of x is mu x and expected value of y is mu y. Happy? This is okay? So because this is linearity, I can use expectation. We can use linearity, not in variance directly. Okay, so if I break this up, what will I get? Expected of value of x squared plus expected value of y minus yx squared plus I will get 2 into expected value of x minus mu x into y minus mu y. Okay. So what is this?
Variance of x plus variance of y plus 1.
Variance of x plus variance of y plus 2 into covariance of x plus y, x comma y. So what is covariance? Covariance is how do they change with respect to one another? How do x and y change with respect to one another? So if one increases, say, if x increases, if y also increases, this is called a high covariance. positive covariance or positive correlation. If you divide by x and y standard deviation, you will have a positive correlation. Similarly, if x increases and y decreases, so you will have a negative correlation. Otherwise, if does not change, so uncorrelated. Okay. Is the intuition clear? Good. So see, both of them have the same sign would mean that you would have a increase. Both of them opposite sign would mean you would have it negatively correlated. Independent would mean, now if they're independent, as Monoshrija was pointing out, if they're independent, then what would be covariance? See, covariance being 0 does not mean independent. I will give you a homework. Give example. So homework would be, so I'll write it at the end. We are almost done. Very good. Homework is give example of a random variable of two random variables that are independent, that have covariance of x comma y equal to 0, but are dependent. Okay, this is your homework. Write it. I would like to see some examples in the chat. I will love it. Please give some of the examples. Yes, I'll check them. So, but if they are independent, what will happen? So your expected value of x comma y, if they are independent, can be written as expected value of x into expected value of y. Can you tell me why? So this term covariance of xy can be written as expected value of xy minus expected value of x comma expected value of y. Right? Similarly, as we found the variance term, broke this variance term into square, I am doing the same thing here. Okay. So x and y I will multiply, x into mu y I will multiply, y into mu x I will multiply, and I will get this term. Agreed? This is the way to write covariance also. These three are same. Yes or no? Okay, I'll explain. So what is the definition of covariance of xy? Expected value of x minus mu x into y minus mu y. What is this? Expected value of xy minus x into mu y minus mu x into y by plus mu x mu y. Now tell me, one of you, what is, if I break this up into linearity of expectation, what will it be? Go ahead. Yeah, you have to be loud and quick. No one can hear you. So this is mu x mu y plus mu x mu y is equal to expected value of x comma y minus expected value of x into expected value of y. Agreed?
Yes, sir.
So what is, now tell me, what is if x and y independent? What is this? Expected value of xy will be? So Monoshrija, you will tell me, because you told me if they're independent, then they're 0. Am I audible?
Sir,
How
can
do
you
I
please repeat the question, please?
I'm asking if you said if they are independent, covariance is 0. So what will the expected value of the product of two random variables be? If they are independent. This is the question.
I can guess. I don't know if it's correct. Can I write it as expectation of x into expectation of y?
Why? That is the evident. I know this will be covariance will be 0 if they're independent. So expected value of x, y will be equal to expected value of x comma y. This I can see from the top equation only. But why is it? So xy by LOTUS, what will you write? Xy?
Xy, yes. Xy into
P of x is equal to x, y equal to y. That's it.
Yes.
And if they're independent, I can break this up.
Yes. P of x.
Bas, done. Now separate them. We'll have x, probability of x is equal to x. Yes. Correct. Yes, Hussein, right. So you have expected value of x into expected value of y. So if they are independent, then you have covariance 0. So now you tell me in 1 second what is the covariance, what is the variance of a binomial distribution? Binomial NP, what will be the distribution? Variance of I1 plus I2 plus dot IN, right? Yes or no? Yes. So what will it be?
Yes, so all of them are actually independent.
Yes,
Independent
IID.
classes, so okay, the covariance terms will be 0.
Very good. So it will be n into variance of I. So what is variance of I? We just found. What is this? This is a Bernoulli. Very good, Bernoulli. So it will be NPQ. This is the type of tricks you need to. Whole of statistics is just using linearity and independence. There's nothing else, and conditioning. So let's do another distribution, which is also known as the geometric distribution. So today So today we have today's class is up to 6. So there up to how much ever we will be able to do, we will do, and then we'll continue from next day. But I think we'll be able to do more or less most of it. Let's see. For geometric distributions, so there are number of trials required for the first success is what is measured. So there are few questions I've given, define the PMF, expected value, variance of it, and also prove the geometric is the memoryless property. So variance I may not do. I am feeling very lazy to do that. You may do it, but I'll show you how to do mean. You will do the variance. So variance you will do as a homework. I'll tell you the answer though. Let's do. So X is geometric. This is a very interesting distribution. Say just think of just think of a sudden death tournament. Okay, such that you are going to keep on scoring. So here the idea is, think of a game where you are playing football and there's a goalkeeper and you are scoring, you are playing, the striker is hitting the ball, he or she continues to play until and unless there's a goal, right? You continue. So you will do something like fail, 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 and you'll pass, right? So this distribution talks about number of trials required to pass the test. So did you understand what I said? And each of these are Bernoulli P. So each of these trials would be by Bernoulli P. Do you understand? If you understood, I'll be asking how to for each of the PMFs and all. So one of you tell me what would be the PMF of the random variable.
So the first try, so the first like n minus 1 try will be fail, and the last try will be.
Yes. So first I want you to tell what values can x take.
It can take like from 1 to infinite, any number of values.
Very good. X will be 1, 2, infinity. So x of omega will be all these values. So k greater than equal to 1 would be, what will it be? So first n minus 1 trials will be failure, right? And these are IIT. So I can use independence, right? They are independent and identically distributed. So go ahead, Aditya.
So it will be like 1 minus p times k minus 1 into p.
Very good. So is it clear to everyone? So I have so k minus 1 into p. Is it clear? All of you? K minus 1 failures, one by one after the other, and one success. Very good. So this is your PMF. So question 1 is done. Now expected value. What is the expected value? So on average, what is the number of trials? So expected value will be, so say you are taking a test, you are given an exam. Until and unless you pass the test, you will not be able to be promoted. So you have a probability of 80%, say 50% of passing the test. So on expectation, you will be giving the test twice. This is the intuition, right? If you have the probability of passing the test as 50%, you will be giving on average 2 times the exam to pass it. That's the intuition. So what would be the probability? What would be the expected value of x? Number of times, number of trials required to pass the test?
1 by p.
How do I do it?
Yes, it will be an infinite. I is equals to 1 to, oh, sorry, a is equals to 1 to 8.
So this is k into probability of x is equal to k. K equal to 1 to infinity, right? Now what will I do? How do I solve this?
E is equals to constant, so this is actually an AGP.
Correct. So how do I solve this? Let's see. I have two ways to solve this. First, I'll do the geometric or the algebraic way. See, what is this? K equal to 1 to k equal to 0 rather. K equal to 0 to infinity. What is this sum? If x is less than 1?
1 by 1 minus x.
It's a GP, right?
Yes.
So it's a GP a by a minus r. So a is 1, x 0 is equal to 1. So, and the factor of the geometric progression is multiplying by x. So I need a k outside, right? So if I differentiate both sides, I will have something like this. 1 to infinity. Because the 0th term will go to 0, it's a constant. Yes or no? Correct?
Yes.
Just put it here. Put x is equal to p my 1 minus p. So what will you get? P into k into 1 by 1 minus p squared, which is p into by p squared is equal to 1 by p. Okay. And homework, variance of x will be q by p square. Please check. exact same procedure you will do, you will get it. Or can you tell me a different way to solve this question?
Sir, can we use binomial theorem here?
Exactly,
like
binomial, same thing only. Binomial theorem you can use, you will get the same thing. This is the AGP only you will get.
Oh.
I'm saying without using algebra, can you solve this? So let's do a recursion. Say C be the, or B, say expected value of X is the number of times to pass the test. So what will I do? So you can say expected value of X can be written as, what can it be written as? So at the, say you are in the pth trial, right? So your current trial, okay, can either be a success or a failure, right? Till now you have come all this way. This trial can be a success or a failure, yes or no? So you have come expected X. Go ahead. Yeah, tell me.
The last term will be success.
Yes, success or failure. So if it is a success, which probability P, so how many terms will you get here? So one more term, right? Yes or no? Similarly, if you have a failure, you can write this as, we will see if it is a memoryless property. So you can write this as expected value of X plus 1, as if you are starting the experiment again. Start the experiment again. Okay. So you see what will you get? So expected value of X is equal to P plus Q into expected value of X. P plus Q is equal to 1. And you will get 1 minus Q expected value of X, which is equal to 1 by P. This recursive definition also you can do. So why can I do this? Because there is something called a memoryless property of a geometric. What does it mean? Geometric's expected value means, say you have done the experiment for S times. What is the probability that you will be requiring to do it for T more times? Means here. So it is, you can see that it is effectively restart from 0. So I'll give you an example. I'll give you a naive example. For example, let's say a couple has a baby, and if I told you from beforehand the couple is going to have 2 babies, you'll be knowing for sure that 50% of the times you will have one male and one female. But given that the couple has one male baby, the next baby is not going to become 100% times it will become a female. It will still remain 50%, because it's as if you're starting again. Do you understand? So, or think of a bus stop. If you have waited for 50 minutes in a bus stop and you have not got a bus, if you think that it's a geometric distribution every minute, then it's as if you are starting that experiment every time again. Every time you see the clock. Did you understand the intuition? So let's see, what does it mean? So what is the probability that X is greater than T? How can I write this? Let's do this memoryless property here. So probability of X greater than or equal to T given X greater than or equal to S. What can I do? How can I write this? Probability of X greater than or equal to T, X greater than or equal to S, by probability of X greater than or equal to S, by Bayes rule, yes or no? Probability of A given B can be written as A by B, right? Probability of A comma B by B.
Yes.
A intersection B can be written as probability of A G given B, right? So what is this? The numerator. This is effectively writing probability of X greater than T, because if X is greater than T, it will always be greater than S, right? So this is a subset of this. Do you agree? So these two events, if it is greater than T, this will always be also be greater than S, yes or no? If T is greater than S. So if a random variable is greater than T, says here, it is bound to be greater than S.
Yes.
So these two conditions are redundant, right? So in the numerator, you may not use this because it's a subset. What does the intersection of two mean? All these two, what does the intersection of these two mean? This is means that's X inverse of X greater than T and X inverse of X greater than S is the superset. So intersection of this will just be the subset, yes or no?
Yes.
So you will have this. So what is going to be this? What is the numerator? Is the sum of K. For the timing, let's just write greater than instead of writing greater than equal to, both are same. Easier to calculate. So K equal to T to infinity. Probability of K minus 1 into P by summation of K equal to S to infinity 1 minus P to the power K minus 1 P. Now do you agree I can cancel this and remove S from here? Yes or no? Yes or no?
Yes.
Did you understand what I'm writing?
No, can you just explain the last line, like where you are?
So say T is 5, right? And S is 3. Agreed?
Yes.
Yes. T is 5 and S is 3. Just let me check once. T is greater than. So 3 to infinity you'll be having here, right? I may have. Just a second. Let me just write S and T is greater than this. So T has to be greater than. Yes. Good. Say T equal to 5, right? We are taking this example again. And S is equal to 3. So what would be the first term of the numerator? 1 minus P to the power of 4 into P plus 1 minus P to the power 5 into P, right? And so on. Agreed?
Yes.
And what would be the denominator's first term?
So there won't be P, like P is independent, so we can just neglect that.
Correct. So you will be having 1 minus P to the power 3. In our case, 2 to the 2.
Yes.
2 comma P and so on. Agreed?
Yes.
So if you take from the numerator, if you take this common, this thing, this sum you can take common, right? From the numerator. So if I take something common like 1 minus P to the power of, so the denominator is already contained in the numerator. Do you see that?
Yes.
what do you take common from the numerator? You will take common as 1 minus 2 to the power. Yes, comma p. If you take this common, you will be left with 2 minus 2 minus 2 and so on. And your denominator will be cancelled.
Okay.
And you will be left with, this would be equal to probability of x greater than equal to t minus s. So what does it mean effectively? Can you tell me?
Yes, like if a device is, let's suppose, work more than like 1 year, so it will, if I say that it will work more another year, so that is not dependent, like how much time it has.
If I say that if it has worked 1 year, if it is not actually always going to be true, but given that you have worked 1 year, if you assume geometric or exponential distribution, the probability that you will be working for 1 more year would be the same as if you're using it as a new device. Understood?
Yes.
Doesn't give you any more extra information. So I think we'll not be able to go into continuous distributions. We'll complete these two and stop today. So for Poisson distribution, what happens? So Poisson distribution, if you want an intuition for it, it is, say you have large n. For example, what was the problem with binomial distribution? Binomial NP. N was finite, right? Do you agree? N was finite.
Yes.
Now if I make n infinite, then see n I will make infinite and the probability of success I'll make very small. Very small, but number of trials will be infinite. For example, receiving emails in a day. So if you take x every minute, if you measure receiving emails in a day per minute, if you measure per minute, what is the probability of receiving emails in a day? It's very small, right? Every minute, every second, if you say every second in a day, so what would be it will be very, very small or not? If for 1 second, now what is the probability I'll get an email? Very small? Yes or no? Getting an email in 1 second window. If I have this thing over a day. So here n is very large and p is very small, right? So if I take each second to be a indicator, so p of that indicator will be very small. Yes or no?
Can you just repeat what last line?
So you have a day, right? Starting from 12 a.m. to 12 p.m. Right? And every second I check. So jth second probability of receiving an email. Right? So there are 16 to 24 seconds in a day, right?
Yes.
So if you have so many seconds, so for in a day, how many emails do you get? 5 emails maximum. But then for every second, the probability of getting an email is very small. Do you agree?
Yes.
So in these cases, and n is very large. Do you see that as well? So in this cases, binomial is not a good option. If n tends to infinity, p tends to 0, and say np is a constant, which is expected value or lambda, which is also the parameter of the Poisson process, Poisson distribution. Then another example could be raindrops in an area. So if a rain is falling, what is the raindrop or probability of having a raindrop in 1 centimeter square of area? This is another example, and so on. So in that case, you can approximate a binomial as a Poisson. Let's do it. How do you approximate it? Say probability of x is equal to k. What will it be? The n is very large. So what will it be? Tell me. N choose k. I'm going to write p to the power k 1 minus p to the power n minus k.
Yes.
Okay. Now, if n is infinity, I will have n factorial by n minus k factorial into k factorial, right? P to the power k 1 minus p to the power n minus k, right? I will put limit n tends to infinity. P tends to 0, right?
Okay.
So what can I do now? So I can cancel these two, see. So these two I can take together. So see how will I do that? So n, k is a finite number, okay? So I can write, if I cancel this with this, I will have n into n minus 1 into n minus 2 dot 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 n minus k plus 1. Agreed?
Yes.
By k factorial into p to the power k 1 minus p to the power n minus k, right?
Yes.
Next, what will I do? Tell me. So these, since these are constants, this can all be written as n to the power k. Yes or no?
So like if n is very large, like the
Infinity. L is tending to infinity. These are finite. So I can write n p to the power k by k factorial, right? And limit n tends to infinity 1 minus p to the power n again. This tends to, this is n minus k tends to n again, right?
Yes.
So np I have said is equal to lambda, right? I said, right? NP is lambda. So number over the day, if each probability is very small and independent, so the product of number of times you are trying into the probability of each will be lambda, right? So what is this limit? N tends to infinity. You remember 1 plus 0 to the power infinite form. So if
Yes.
you take log, it will be e to the power minus np, right? This is the limit value. This is the formula, right? So 1 plus x, 1 plus f1 to the power 1 by f2, limit f1 comma limit f2 go to 0, then it can be written as f1 by f2. This is the limit, right? So you will have e to the power minus np lambda to the power k by k factorial. Np is lambda. So this is your Poisson distribution. Okay. So let us do expected value. Variance you can do as a homework, which is also equal to lambda. So what will be the expected value? See, the expected value we have already defined as lambda. So but can we recheck it? The expected value of x, what will it be? K into lambda to the power k by k factorial to the power minus lambda. K equal to 0 to infinity. Yes or no? K
Yes, sir.
probability of x is equal to k. So how do I do this now? So e to the power minus lambda is a constant. K lambda to the power k by k factorial. What is this? Again, what is x to the power k by k. Yeah.
Yes,
go ahead.
we can take one lambda outside, and that will lambda to the power k minus 1 by k minus 1 factorial exponential.
Very good. So, or yes, so you take one lambda outside and this. So this is the derivative of ddx of e to the power x, right? At x is equal to lambda. So you have lambda e to the power minus lambda into e to the power lambda, which is lambda. Similarly, you can do it for lambda square as well, which will also be the same. Last thing for today is the negative binomial distribution. And please solve this and upload it. So before the session, next session. See that it's a for the negative binomial, it's going to be 1 second work. What does it say? It's like a say a tennis match. So for a tennis match, so you need to have 4 points to win a game, right? Provided provided that the opponent cannot win it until and unless you win the 4 points, you will not win. That's the idea. So you have to win a say you will have to win k successes, right? For k successes in the nth trial, how many? What is the probability? So for the k minus 1th duration, what will happen? So kth, you stop at the kth, so you have a success, right? So these are all by Bernoulli p distributions. So you have kth success in the nth trial. So what will you have in the last k minus 1 trials?
Will it
Go
be
ahead,
n
Aditya.
minus 1 trials? The total number of
n minus 1 trials. So what will you have? So
k
n
minus
minus
1 successes.
nth trial. So you'll have k minus 1 successes, right? So someone else tell me what will be the probability that x is equal to k. Means you require k chances to get the nth success.
We can form it as like we choose any k minus 1 trials from n minus 1 trial, and we like win those, and rest we lose, and the last trial we win.
Yes, so wait. So nth to get the kth success, or rather, so get the kth success. And what will your random variable tell? Number of trials. You require n chances to get the kth success, right? Okay. So what will it be? What will be the probability be? So you will have in n minus 1 trials. So n must be greater than or equal to k. Do you agree?
Yes, sir.
So for having 5 successes, at least 5 trials you need. You cannot do get before 5, right?
Yes.
So n greater than k. So what will I do now? Tell me. So out of n minus 1, k
We
minus
need k
1
minus 1
successes.
successes.
So what will it be? So n minus 1, choose k minus 1.
Times p to the power.
Binomial, right?
Yes.
P to the power k minus 1, 1 minus p to the power n minus 1 minus k minus 1.
K plus, yeah.
Into p for this. So this is equal to n minus 1 k minus 1 p to the power k minus 1 1 minus p to the power. This is the distribution you will get, right?
Yes.
So but see, Why is it called a negative binomial? First of all, it's as if you are doing x plus 1 plus x. You can see this at home to the power minus a. Phi is a positive number. Second of all, in binomial, do you remember it was k here and n that was fixed? Do you remember that? But here
Yes.
n is not fixed. N is changing. But k is fixed. So it's the opposite of binomial, right? So PMF we found. Can you tell me an easy way to find the expectation and variance so that I can complete in 1 minute? Someone else who have understood binomial and linearity of expectation.
Like I have an thing in mind. Like we can multiply and divide by k. So the first choosing term
No,
becomes.
I can algebraically you can do that. I know. I want to know one indicator random variable formulation. I'll give you a hint. So you have failures, right? And then you have a success. Agreed?
Yes.
Again, you have some failures and then you have a success. Then again, you have a success, you have some failures, and then you have the kth success, right? So can we divide these into indicators in some way? We have done this already. So
Getting one success.
first, exactly. Others, do you understand? So this is a geometric, right? So I1 is, what will it be? So you can write X as, this is exactly not going to be indicators, but you can write it as Y1, or since they are geometric, G1, G2, G3, and G4, right?
Yes, like for some we are losing and then we are winning one.
And then you restart the experiment. So this is one experiment. This is one other experiment. This is one more experiment. This is another experiment, right?
Yes.
So this will continue up to GK, right?
K. Yes.
You need K successes. So others, did you understand? So this is linearity of expectation. How did I use? GI is number of trials to get ith success after I minus 1th success. Yes or no? Subhojit,
Yes.
Hossein, Brahmojit, Bonusrija,
Yes, sir. Okay.
Ritik.
Yes, sir. Okay.
So I can divide. So now what will I do? Tell me. So these are all geometrics, right? So one success you want at the end. At the end, you need one success. So what is expected value of X? Summation of expected value of GIs?
Yes.
Yes or no?
Yes.
Yes or no?
Yes.
So what is the expected value of GI?
1/2.
1 by P.
Everybody is understood. Ritik and Monastrija did not, and Irfan did not answer. So it's 1 by P, right? So it's K into 1 by P. What will be the variance then? They are all independent.
Yes. So
Huh?
variance distributed.
So this will be k into variance of gi. What will be that? 1 by p square, right? Or some 1 by p square or q by p square? I don't remember. Please check it
Q
once.
by p square. Q by p square.
Yeah. So it's q by p square. So just check it once and tell me. Both are correct, but there's a small catch, because if it is q by p square only. Let's just check. I don't remember exactly. I need to I derive all these things every time. So let me just check it once. And variance was q by p square, q by p square. Yeah, q by p square, I think. Yes, it's q by p square only. I don't. Yeah. So we end it today here. So do the homeworks the rest of the day. So is it okay if we finish off the third session tomorrow morning from 9:30 to 12? We'll have a smaller session. We'll not have this long. If it is okay, I'll schedule it tomorrow morning, and then we can have the next session next week at next weekend, so that you can do
Tomorrow.
Sir, 9 to 12 morning. So can it be in the evening or afternoon?
Evening or night was better.
9:30 is a problem. So tomorrow is Sunday.
Yes, evening or like night, like you took yesterday.
Evening or night in that time.
Okay, then we'll do it from 3 to 5:30.
It's an evening. I have somewhere to go tomorrow actually.
Okay, then we'll do it from 5.
7.
So that will be very late. That actually we have dinner. Wait, I'll just stop recording.